So now what we have is a very special section of our activity. It's something new. When we went to the previous schools, we didn't have this. Even though we are giving all the talks and activities, now each of us are going to talk for 2 minutes or maybe less than that to tell you guys what we are doing, because that might be more helpful for you. I know one of you might want to become an engineer or want to get into space technology, like space engineering or mechanical, or maybe a doctor, but we can't talk about medical because none of us are doctors. So we're going to talk about something which we are doing in a language where you can understand. Let's see how good we will do. This is here. And this is Samyaday, so he's going to talk about what he's doing.
Okay, good morning all of you.
Good morning.
That's a big name, Samyaday, you can call me Sam, that's a lot easier. Okay, so you all enjoyed the talk?
Yeah.
Space exploration, going to Mars, going to moon, everything. So, so Shripathy explained very nicely, how often we set our limits and then we go and push ourselves and we again cross that limit and set a new limit. So we are going to do something similar. So Shripathy talked about exploring the space, knowing about the planets which are near to us, knowing about the sun. So the solar system. So before I sort of push ourselves and go beyond the limit which Shripathy has said, we'll talk about something very usual, something which is very common to all of you. So we stay in different parts of Bangalore, right? Some of you stay in Koramangala, Nayanagara, or which other places. We stay near this Madibala, we stay in a hostel. So for example, you consider your house or the building in which you stay. That's your house, that's your home. And now, there will be some families or there will be some building which are near to you, right? You call them neighbors, right?
Yeah.
And then there will be neighbors of those neighbors, neighbors of those neighbors. And then what you have is a whole locality, a small locality which you say a block, Koramangala first block, Koramangala second block. And when you sort of integrate or when you add all those kind of blocks, what you get is a whole area, say Koramangala, which comprises of block 1, block 2, block 3. And what if you add so many Koramangalas, what does it end up with? It forms Bangalore, right? Bangalore, a huge city. Okay, so Bangalore is sort of comprised of a lot of buildings, right? Hundreds and hundreds. For now it's thousands and thousands of buildings. Okay. Now, let's talk on a bigger scale. So, in space, where do you think our home is? The solar system? Solar system is our home? Solar system? Okay. So, the sun, it's the source of energy, it's the source of light for us. And in the universe, when you, for example, you look at the night sky, you see, many stars. So there are some stars which might be, brighter and, bigger than the sun. There are stars which are smaller than the sun, which are dimmer than the sun. Okay. So we know how the colony or city comprised of, buildings look like. So how does a city which is made up of thousands, not only thousands and thousands of stars, but say around 1 billion of stars look like? So which is the city that we live in? The city of stars where we live in?
Milky Way.
This is the one? Milky Way? Which has about say 10 to the power 11 stars. So it's this Milky Way is nothing but a whole city of stars, okay, which has about 10 to the power 9, 10 to the power 11 number of stars, and we call the city of stars as
Galaxies.
Okay, that's the more general or astrophysical term or astrophysical a galaxy, right? So for example, you're in Bangalore, you go to the top of the highest building at night. So what do you see? You see all the street lights all around you. So isn't the picture very similar to this? For example, you're standing on a tall tower and looking at it. So it's like, you see all the lights of different buildings all around you. So this is the city, a big city of stars. Okay, we call it galaxy. So, is there only one galaxy in this universe? There are many galaxies, right? So some of our neighboring galaxies, for example, you have Mysore near to us. There's a city called Mysore which is near to us, which is smaller as compared to Bangalore. So there is one small galaxy, which is two small galaxies, in fact, which are near to the Milky Way. It's called the Large Magellanic Cloud and the Small Magellanic Cloud. Okay, apart from this, you have another galaxy which is around 2.5 million light years away, which is also, sort of near to the Milky Way. Andromeda people are here, like, raise your hands. Okay. So Andromeda, and there are Sagittarius dwarf galaxies. So there are many galaxies in this universe, right? So now the question is, what I told you is, a galaxy is made up of stars. The building block of a galaxy is stars. But is it the only component which is present in a galaxy?
No, that's not the gases.
Okay, let's find out. Let's find out from our friend.
Okay, so all of you have learned from Shripathy a little bit about our planets, right?
Yeah.
So you know a little bit about the solar system on a small scale, and now Sam taught you a little bit about the galaxy, which is a much bigger picture, right? And all of you would have heard this term: space is full of vacuum. You all heard? What do you mean by vacuum? Empty, there is nothing inside, right?
Yeah.
But did you know that space is actually not vacuum?
Yeah.
Okay. No. What we do is, let's imagine that this classroom is a cube of 1 centimeter height, 1 centimeter width, and 1 centimeter breadth. Then what is the volume of this cube? 1 into 1 into 1, 1 centimeter cube. Can you imagine if this is a molecule? Okay, so this is a 1 centimeter cube space, and say this is a molecule. Can you guess how many number of such molecules will be in this space? Just take a wild guess. This is a molecule. How many such balls do you think will be there in such a small space on Earth? It's not infinite, but it's a very large number. Take a guess. Guess some number. Thousands? 10,000? Billion? You want to know the real number? The real number is 50 quintillion. Have you heard of the term quintillion?
No.
You know that kilo is 10 power 3? Kilo means 1000, right?
Yeah.
Billion means it's 10 followed by 6 numbers. Quintillion is 10 followed by 18 zeros. So it is 50 into 10 to the power 18. So in such a small space, that is 1 centimeter by 1 centimeter by 1 centimeter on Earth, you will have 50 into 10 to the power 18 molecules. In space, in the same volume, guess how many molecules will be there? Earth has more molecules, right, compared to space. We say space is vacuum. So will space have more molecules or lesser? Lesser. How less? Guess the number. Take a guess. Guess a smaller number. Start guessing smaller numbers. Million? Smaller. 100. Smaller. Smaller. Who was it? 0.1. Okay, so on Earth, in such a small space, we have 10 to the power 18 molecules. But when we go to space, there will hardly be one molecule in the same space. So that's why, compared to Earth, we call such space as vacuum. Alright? But why does this one molecule matter? It's just one molecule, right? What happens is, you know the stars are very far away, several light years away. So when you count the number of molecules which are so far away, even though it is one molecule in 1 centimeter cube, because the stars are so far away, if you count the number of molecules towards one star, it will add to a considerable number. right? So, what if it adds to a big number? How is that going to affect anything? Louder. How does that matter? What if there are molecules in between stars? How does it matter? Here it matters because we are breathing the air. What does it matter to the stars, and what does it matter if there are some molecules just floating in the air over there?
Propagation of light in the space. Light, of course, distance. Light years we are going to come to know. The distance, propagation of light. Distance from the star and the planet.
What happens is, all of you would have seen fog early in the morning?
Yeah.
Say there's some very far away building which you see every day. What happens if there's a big thick fog?
You can't.
You cannot see the light. You cannot see the building, right? But you'll be able to see something which is very close by?
Yeah.
Right? So the thicker the fog, the closer the building you'll be able to see. You won't be able to see far away buildings, right? And if there's no fog, everything even far away will be very clear. Correct? So you see a very similar effect even with these, even though there are very few molecules. If you have a star which is very, very, very far away, then there will be so many molecules in that line that you will not be able to see the star clearly anymore. So even if you use a telescope, it will become difficult to see because the starlight is not reaching us. So what I study on is I am studying how many such molecules are there towards different stars. So if we have a closer star, there will be less number of molecules. Correct? And the light that we are receiving from that star will more or less be full. But if there's a little far away star, then we won't be receiving all the light. So if I can find out how many molecules are there towards each star, I'll be able to correct for that effect. And I can find out how bright the star really is. Alright? So do you all want to actually see what such a place looks like?
Yeah.
Okay? See, in space there are areas where you'll have maybe only one molecule, but then there'll be some places where there'll be little fewer more molecules. So these are called gas and dust. These are molecules of mostly hydrogen and little helium. Alright? So this is mostly gas and dust. There is one such object where the gas and dust has accumulated more and it is visible to the naked eye. Do you all know where? There is one small region in sky, or there is one small such region in the Milky Way itself, and that is visible to naked eye. You all know constellations?
Yeah.
Okay? And have you all seen these 3 stars in a line? Orion constellation? You all recognize this constellation? These 3 stars in a line? This is visible from Bangalore now. If you go at night and have a look up, you will be able to see these 3 stars in a line. None of you have noticed this? So just today night, go look at the sky, find these 3 stars. This is the Orion constellation. After some time, we will be telling you how to find and identify different constellations. Okay? So that time you will know how to identify Orion constellation. Once you find these 3 stars, do you see there are 3 stars down over here?
Yeah.
This is called the Orion constellation. Orion the hunter. Have you all heard that?
Yes.
Okay. So these 2 stars over there are Orion's shoulders, and these are part of his legs. This is supposed to be Orion's belt. And you see these 3 small dots over here? This top one is a star. The bottom one is a star. But you see in the middle something reddish in color? That is not the sun. No. That is actually the Orion Nebula. So that is one region where there is a lot of gas and dust. So if you go and look at the night sky and if you identify this object, you will see that it's not as clear as a star. It will look like a very small cloud. Okay? So try to have a look at that. So now you know a little bit about solar system, you know about galaxy big scale, you know what is there in the galaxy other than stars. But what are the stars sensors made of?
That's
So follow this.
hydrogen gas.
Deal with her. Susmitha is coming up next to talk about that. And this is the photo of that nebula which has been taken with a telescope. The Orion Nebula. So, now you know what is there in the Milky Way galaxy? What? Only stars. Planets? Stars? So, can you say what this is? When you look at the sky, you see this one, right?
What is it? Stars. Now, how can you see the stars in the sky?
They will twinkling. How you find the star? They will twinkling a bit brighter.
Yeah, brighter. Now, have you ever thought that why they shine? Why the stars shine in the sky?
Yeah.
Why?
The hydrogen is compared to the temperature ranges, so it glows.
Okay. So why do they shine is like there are certain kind of reactions which happens inside the star. That's why these stars are shining. Kind of burning process. It's not exactly burning, but it's kind of a process which happens inside the star. So do you know what kind of reactions are that? Nuclear reactions. Specifically?
Fusion.
Nuclear fusion reaction, which means lighter elements will combine to form
A heavy.
heavier elements, right? So what is basically which gives out the shining? What will combine to form?
Hydrogen.
Will combine to form helium. Many, like all the stars which we see in the sky, they shine because of this hydrogen combines to form helium, which gives out heat and light, right? So we know heat and light are the products which comes out of, what we can see in the sky. So these are the light which we can see, and that is because of this combined reaction. And you know how many elements are there in the periodic table? 117, 116, yeah. So, are you able to get all the elements on Earth, like? Only few. Why? Because we need higher temperature to produce all these elements. Many of the elements need higher temperature, all of the elements. So, the stars are actually an ideal laboratory for all these elements to be produced. So when we study about stars, we will get to know about the elements which are produced and the various mechanism which is happening inside the star. So can you say how can we get to know about all these processes that are happening inside the star? How do we get to know about all these things? Spectra. You know what spectra is? Leave the name. Just a name you remember when you go further for studies. It's a spectra, meaning just light you split into different colors, like you see in a big bag. You know white light can be different colors. So that is a spectra. Just a word you remember. So from the star light we can study about their temperature. And the elements I told you, right? Many elements are there producing inside the star. Those can be studied. The temperature of the star and the age of the star and how far the star is. So these are the main things which we study about stars in the sky. Now we need to see stars in the sky, right? So Avinash will help you to say something which is about the stars which are very far, how to see that, the mechanism which will help you to study all these things.
Good morning, everyone.
Good morning.
My name is Avinash and I am an engineer. So far, the three people who had talked were scientists, Preethi, Susmitha and Sam. So they look at stars, they want to find out the spectra, they want to find out the properties of the stars, they want to look far and wide. But we are the ones who help them see far and wide and much more clearer than ever before. So how do we do that? Telescopes, right? So have you seen, who all have seen through a telescope? None of you have seen through a telescope. So you will have an activity where you can see through a telescope. We have brought our own telescopes. So when you want to see really far away, as Preethi told, there are lots of dust and gas and whatnot ever. So we can't see anything through our naked eye, right? So we have to see in a different color. That is one thing. Have you heard of infrared? So infrared is a color. When you observe an object, when you see a star in the infrared region, it goes through all the dust and gas and everything. So there is a place at the center of the Milky Way. We don't know what it is. It's shrouded by dust, gas, and so many other things. Our naked eye cannot penetrate it. It's been shrouded in mystery for such a long time. So now we have the capability to see in the infrared. We have cameras that can see in the infrared. Right. So that is one thing. The second thing is, when you look on a smoggy city like Bangalore, filled with pollution, mist, cold climates, whatever. So when you look far away to the buildings, you can't even see the buildings. How do you see stars? Right? It's very difficult. Yeah, on a very clear night, it's really far away, you can see the stars. But you must have seen the stars twinkling, right?
Yeah.
Why do they twinkle?
Refraction.
Because there is a layer of air above us, right? So because of that layer of air above us, the temperature changes and everything that is associated with it. Yeah, the light which comes refracts. It's just like it comes through glass or water. So the atmosphere is constantly changing. So when you point a telescope at a star, if the star is constantly moving because of the atmosphere, how can we observe the star? We cannot, right? So how do you do it? So that is the next thing we have to solve. First is interstellar dust and gas. Second is the atmosphere. We have to take care of two things, right? So this is the moon, which is observed with a telescope, right? So when you see here, even the moon is twinkling. See the edge of the moon. It's not exactly clear. It's all blurry and it's like seen through water, right?
Yeah.
When you see something through water, it becomes all wobbly and things like that. So when we look at things which are much far away, the effect is much worse. We hate the twinkling of stars. So what do we do? There is a technique now called adaptive optics. I won't go into the details, but this is what it does. So this is the surface of the moon without adaptive optics, and this is with adaptive optics. This is observed from Earth. This is not on, we are not standing on the surface of the moon. This is with a telescope from Earth. This is without adaptive optics and with adaptive optics. So with adaptive optics, see how clear it is. All the craters and everything. From Earth, we are capturing this image. Now we look far away. This is the center of the Milky Way. See, with adaptive optics, how clearer it can be. To change the complete effect of the atmosphere. It's like sending the telescope to space itself. It's like there's no atmosphere at all. If you look the zoomed up part, we see that there are several stars here. So, if you see here, if we just look through a telescope, this is what we see. But when we apply the technique of adaptive optics, we see stars much clearer. So this is an image of Uranus, which is without adaptive optics, and with adaptive optics, it's much beautiful. And this is in the infrared region. So this is the light which is in the infrared region, which is converted to a form of light in which we can see. Right? So these are some of the images which has been captured with the help of adaptive optics. See Saturn. Uranus. This is the globular cluster, lots of galaxies, nebulae. It has opened our vistas far and wide. So this is an image which is, this is a very famous image which was caught in the span of 16 years. This is the center of the Milky Way. You see these stars, these are all stars. So at the center of the Milky Way, if you see, these stars are rotating around something which you cannot see, which you have no idea what it is. There is a black portion here, and around that black portion, all the stars are rotating. Do you have any idea what it is? What must be there at the center? Black holes?
Yeah.
Maybe. So I invite Prashanth to continue talking about black holes.
So
as many of you all have already guessed, right? You all don't see anything in this region. Now we know that the Earth and all the other planets move around the sun, right?
Yeah.
Now we can see the sun from here, right? Now what happens if you are sitting on one of these stars? Will you be able to see what the star is going around? No, right? From this image we don't see anything at the center around which it goes. So that object is called a black hole. So what happens around the black hole is called the theory of gravitation, which was given by, who is the most famous physicist we all have heard of? Einstein. Yes, right? So gravitation was given by Newton, and then the recent one is given by Einstein. So what he said, what he gave as one of the proofs of his theory was that even light will bend when it goes near any massive object. So that was proved in 1919 when we saw light from a star just behind the sun being bent by the gravitational field of the sun. Now, so what a black hole does is this. So imagine this is the black hole. Even light cannot escape from the black hole. So the reason why we call it a black hole is because we don't see light from it. You saw the image where all the stars are moving around, right? We didn't see anything at the center. So that's because the light from that region is being sucked into the black hole. Now, how big or how massive is the black hole? Assume the sun is a sugar cube. Everyone's seen a sugar cube, right?
Yeah.
So the sugar cube would be a few grams, say 1 gram. Okay? Now the black hole would be 1000 kgs. So that is the size of your school bus or something like that. So if the sun is only this small, the black hole is so huge. So if the sun can bend light, the black hole can suck it in. Okay? So for the next part, we'll tell you how astronomical objects can be seen. So Nirmal will tell you about what we are doing to look at astronomical objects.
So as Avinash said, that atmosphere poses some problem with seeds, that you know, right? So can you suggest any method that can avoid this atmosphere and see the stars? Anything? Any suggestions? Avoid the atmosphere and see the objects. Okay, I will tell you. We will take telescope and go to space and see the objects. That's what satellites do. Hubble telescope. Have you ever heard about it? Yeah. Hubble telescope. But the thing is that it's very costly. So we have to find some cheap way. One of the cheap ways is balloon technique. So what we do is we send one telescope in balloon in the higher atmosphere and see the objects from there. But there is one problem. There are no person to guide the telescope. So we have to make some mechanism to guide the telescope and to point to the stars and see the objects. So if you are working in electronics or mechanics, the astronomers need you. Like people need astronomers need electronics and mechanical engineers to do this thing. So if you are going for electronics or anything, you can't be an astronomer. So you can be an astronomer even if you are electronics or mechanics engineer. So I will call everybody to talk about the astrophotography thing.
Okay, till now you learned about science, right? Astronomy as science, galaxies and black holes and everything.
Yeah.
But there's one aspect about astronomy which is very beautiful. You know, astronomy, even though it's a science, it can also be art. So astrophotography is actually you photograph and take an image of something which is far, far away, millions of light years away, or even farther than that. So this is called, why do you think you have these lines there? Because Earth moves around the sun and Earth rotates itself, in its axis. So when you keep a camera for a long time, looking at the sky for a long time, the stars will move from east to west around the North Pole star. So that's what happens. See, the tree hasn't moved, but since the Earth has moved, because of which the stars look like it's moving, and this is where the pole star is. It's the pole star. That's where the whole, it looks like the whole universe is rotating. And so they talked about Milky Way.
Yeah.
And you know what? You can actually photograph Milky Way. So when you go a little bigger, and when you have your own camera, but more than everything, you need to go to a place where there is no light pollution. Because tonight, if you go and look up, because of the light pollution, Bangalore is full of people and lights and pollution, dust. So you cannot look up and see a clear night sky. You go out of the city, you go to a village where you have a clear night sky. There, you see a white patch, a long, it looks like a hazy white cloud in the sky, and that's Milky Way. You know, right? Sun is at the edge of Milky Way.
Yeah.
So if this is the Milky Way, it's a spiral galaxy, and you are at the edge, and you look towards the center of the galaxy, this is what it looks like. So you can actually see that. And this is one of the photographs taken in Australia. So the best thing about taking a picture of the night sky is to have something on our planet, because that's where you find the connection. If you just look at the sky and take a picture, that's really good. But if you can have something of our own, imagine, this tree is maybe 200 years old, 300 years old, and the house behind is maybe 40 years old, and you just look up the stars, which are billions and billions of years old, right? Like maybe more than a billion years old. So this is the connection what we have, and when you go out, when you go out and look at the night sky, and moon is such a beautiful object to look, and this is how it looks on a full moon day. And again, as I told you, the connection. So when you have a clear night sky, this is how the sky looks like. It was taken in one of the villages in Karnataka. I was taking a picture, and you have no light pollution. So this is what you will see. And they talked about galaxies and nebulae, right? So this is called Triangulum Galaxy, which is 30 million light years away from here. It's very far. So what picture I have taken here, this light has traveled so far. So this is the light what we are getting. What we are seeing is, this is how the galaxy was 30 million light years away. You know, right? Because light takes some time to travel.
Yeah.
And this is how it was 30 million years before. And this is our Indian Institute of Astrophysics. Radio, which is one of our campus in Hoskote. And if you see properly, can you recognize this? Orion constellation, right? Preethi talked about that.
Yeah.
So you can actually see that this is the hazy patch here. You remember?
Yes.
Just 10 minutes ago. Again the same. And what do you think this is?
Not constellation, because it's stars. The stars are in the
It's just an aeroplane. So when you keep the camera for a long time and an aeroplane goes in the screen, this is what happens. So what we need to do this, we need a clear sky and knowledge of night sky, which we're going to tell in next session. And with patience, I tell you, whole night you sit there and you get 2 pictures. But more than everything, you need to go out. You need to go out and immerse yourself in that atmosphere. And now Ankit will tell how to go out and do what. This is the last.
So I'll be talking about stargazing and something known as star parties. Okay. Yeah, it sounds really fancy, but it's really interesting. So, like all of you know that people have been gazing the night sky for centuries now. As Preethi was talking about the Orion constellation, so you know how it looks like. Like you have these shoulders, and then there's the Orion belt, then these stars form the legs, and if you look carefully, there are 3 stars here. Okay, so this is how the Greek people saw the Orion constellation. They saw it like a human figure. It's actually a hunter. But Indian astronomers, they saw it in a very different way, because like the position of India compared to Greece is different. Okay, so if you see Orion in India, it's not upright. In Greece, it's like this, but in India, it's tilted like this. So like when it's directly above you, it actually looks like a deer. Like you are looking at a deer. This is the deer's face, and it's you are looking at the bottom of the deer, like it's running. These are the 4 feet of deer, okay, and this is its belly that you can see. So that's why this constellation is called Mrek in the Indian astronomy terms, like ancient Indian astronomy terms. And yeah, so like why do we associate all these shapes with different constellations, stars in the sky? So the basic aim is like to know about the night sky. Like how can you remember the night sky better? You can remember it better like if you associate a story with it, or associate some shapes or something, some picture that you can keep in your mind. Like if I just tell you that this is Orion, probably you will forget it after some 5 minutes. But if I tell you there is a tail associated with it, like Orion and Scorpius, they are never together in the sky, because there is a Greek story that Scorpius, the scorpion, which is actually a constellation, it had bitten Orion. So that's why like when Orion sets, then Scorpius rises. Even in Hindu mythology, in ancient Indian astronomy, there is a story associated with this constellation. You know about the star called Sirius, right? Yeah. So Sirius is called Vyad in ancient Indian astronomy, and Vyad means the hunter. So Sirius is Vyad, is the hunter. It actually shot an arrow, and which passed through the belly of this deer. So which is the belt of the deer. Yeah, so this is how like you can explore the night sky better, and you can find more interest. So now I'll show you some interesting stuff that I had previously done during one of the star parties in Goa. Like it involves a lot of astrophotography and what Shripathy had earlier said. So like just sit back and enjoy. 8 hours. Like we started at around 8 o'clock or 9 o'clock at night, and we went on till 4 or 5 in the morning.
So all you need is patience.
Yeah.